Welcome to our peaceful journey across the scattered jewels of the Indian Ocean, where 1,192 coral islands drift like forgotten dreams across the endless blue waters of the Maldives. As you settle into comfort tonight, allow your mind to float gently across these pristine atolls, each one a small miracle of coral growth and ocean currents, where time moves as slowly as the tide itself. The Maldives archipelago stretches across 298 square kilometers, or 115 square miles of land, scattered over 90,000 square kilometers, or 35,000 square miles of ocean. A vast expanse of water, punctuated by these tiny islands that rise barely 1.5 meters or 5 feet above sea level at their highest points. I wonder where you might be listening from this evening, what part of our world you call home, and what time your clock shows as these words reach you across the digital waves. Perhaps you might share that gentle information with us in the comments below, creating our own peaceful map of sleepy listeners scattered across the globe. And if you find that these island wanderings bring you the rest you seek, consider joining our community of geographical dreamers by subscribing to accompany us on future journeys to the world's most tranquil landscapes. The name Maldives derives from the Sanskrit words Maldive, meaning garland of islands, a description that captures the delicate way these coral formations are strung across the Indian Ocean like pearls on an invisible thread. These islands began forming approximately 60 million years ago, when volcanic activity deep beneath the ocean floor created the foundation upon which countless generations of coral polyps would build their limestone fortresses. The process continues today with the same patient persistence that has characterized coral growth since the Mesozoic era, each polyp adding its tiny contribution to the reef structure at rates of approximately 2 to 10 millimeters, or 0.08 to 0.4 inches per year. The archipelago extends from 7 degrees 6 minutes north to 0 degrees 42 minutes south latitude, and from 72 degrees 33 minutes to 73 degrees 46 minutes east longitude, positioning these islands almost perfectly along the equator, where the warm waters of the Indian Ocean maintain temperatures between 26 and 30 degrees Celsius, or 79 to 86 degrees Fahrenheit throughout the year. The geological foundation of the Maldives rests upon an ancient underwater mountain range called the Chagos Lacative Ridge, a submarine elevation that extends northward from the Chagos archipelago through the Maldives to the Lakshadweep Islands off the coast of India. This ridge formed as the Indian tectonic plate moved northward over a stationary hotspot in the Earth's mantle, creating a chain of volcanic seamounts over millions of years. As these volcanic peaks gradually subsided below sea level, coral reefs began to establish themselves in the warm, clear waters surrounding each seamount. The corals continued to grow upward toward the surface as the volcanic foundations slowly sank, maintaining their position within the optimal depth range for photosynthesis and feeding. Over geological time, this process created the distinctive atoll formations that characterize the Maldives today. Each atoll in the Maldives follows the same basic structure established by countless generations of coral organisms working in unconscious cooperation. The outer edge of each atoll is marked by a living coral reef that faces the open ocean, where waves crash continuously against the limestone barrier with measured regularity. These outer reefs typically rise from depths of 30 to 50 meters, or 98 to 164 feet, their surfaces reaching to within 1 or 2 meters, or 3 to 6 feet of the lowest tide level. The reef structure creates a natural breakwater that protects the calmer lagoon waters within each atoll, where depths rarely exceed 30 meters or 98 feet and often remain much shallower. The lagoon floors consist primarily of fine coral sand mixed with the skeletal remains of countless marine organisms that have lived and died in these protected waters over thousands of years. The sand itself is predominantly calcium carbonate, ground fine by wave action, and the feeding activities of parrotfish and other reef inhabitants that consume coral and excrete sand at rates of several kilograms per fish per year. The individual islands within each atoll occupy the reef flats, areas where coral growth has reached the surface and continued to accumulate sediment over centuries. These islands rarely exceed 2 meters or 6.5 feet in elevation above mean sea level. Their surfaces shaped by the prevailing wind patterns and ocean currents that deposit sand and coral debris in specific configurations. The typical island profile shows a gentle slope from the central interior down to the beach, with the highest ground usually found near the center of the island, where vegetation has helped to trap and stabilize wind-blown sediment. The beaches themselves consist of coral sand ranging in grain size from fine powder to coarse granules, the texture determined by the local coral species, and the energy of wave action affecting each shoreline. The coral reefs that form the foundation of these islands represent one of the most diverse ecosystems on Earth, supporting an estimated 1,100 species of fish and more than 200 species of coral within the Maldivian waters. The hard corals that build the reef structure belong primarily to the families Acroporidae, Faviidae, and Portidae, each species adapted to specific conditions of depth, water movement, and light availability. The branching staghorn corals of the genus Acropora dominate the shallow reef flats and upper reef slopes, their rapid growth rates allowing them to quickly colonize areas of suitable habitat. The massive boulder corals of the genus Porites form the backbone of many reef structures. Their dense limestone skeletons, accumulating over decades to create the solid foundation upon which other coral species establish themselves. The plate corals and table corals extend horizontally to capture maximum sunlight in deeper waters, their flattened forms creating shelter for countless small fish and invertebrates. As we drift mentally across these coral gardens, perhaps you might reflect on what draws you to such pristine marine landscapes. What aspects of these island environments bring you a sense of peace and tranquility? If you feel moved to share such thoughts in the comments below, many would find comfort in reading about the natural places that soothe our restless minds. The living coral polyps that build these reefs exist in a remarkable partnership with microscopic algae called zooxanthellae, single-celled plants that live within the coral tissues and provide up to 90% of the coral's nutritional requirements through photosynthesis. This symbiotic relationship allows corals to thrive in the nutrient-poor waters of tropical oceans, where conventional food sources would be insufficient to support such massive biological construction projects. The zooxanthellae require clear, shallow water for optimal photosynthesis, which explains why coral reefs develop only in specific environmental conditions, and why the Maldives' position in the clear waters of the Indian Ocean provides ideal habitat for these partnerships. The algae also contribute to the vibrant colors associated with healthy coral reefs, their pigments creating the blues, greens, yellows, and browns that characterize living coral colonies. The fish communities that inhabit these reefs have evolved intricate relationships with both the coral structures and each other, creating complex food webs that support remarkable biodiversity within relatively small areas. The smallest reef fish, such as gobies and wrasses, may measure only 2 to 3 centimeters, or 0.8 to 1.2 inches in length, and live their entire lives within a few square meters of reef territory. At the opposite extreme, whale sharks reaching lengths of 12 meters, or 39 feet, or more visit Maldivian waters to feed on the seasonal plankton blooms that occur when monsoon patterns bring nutrient-rich water to the surface. Between these extremes exist hundreds of species adapted to every conceivable niche within the reef ecosystem, from the algae-grazing parrotfish that continuously scrape the reef surface to the predatory groupers that lurk in caves and crevices, waiting for unwary prey. The seasonal patterns that affect the Maldives are driven primarily by the monsoon systems that dominate weather patterns across the Indian Ocean. The southwest monsoon, locally known as the Hulhungu, typically arrives in May and continues through October, bringing increased rainfall and stronger winds from the southwest. During this period, the western sides of the atolls experience rougher sea conditions, while the eastern sides remain relatively protected. The northeast monsoon, called the Uruvai, prevails from November through April, reversing the wind patterns and creating calmer conditions on the western sides of the atolls. The transition periods between monsoons, known locally as the Hulhungu Maws and Uruvai Maws, often provide the calmest weather conditions with light winds and clear skies. Rainfall patterns across the Maldives show considerable variation, both seasonally and geographically, with annual totals ranging from 1,500 millimeters or 59 inches in the northern atolls to more than 2,500 millimeters or 98 inches in the southern regions. The precipitation falls primarily during the southwest monsoon period, when moisture-laden air masses from the Indian Ocean encounter the slight topographical variations created by the atolls and islands. Despite their minimal elevation, these islands can influence local precipitation patterns through the process of orographic lifting, where air masses forced to rise over even slight elevations cool and release their moisture. The rainwater that falls on these islands quickly percolates through the highly permeable coral sand and limestone, creating freshwater lenses that float atop the denser saltwater below. These freshwater lenses represent the primary source of drinking water for the natural vegetation, and historically, for human populations on these islands. The lens of fresh water typically extends only 1 to 3 meters or 3 to 10 feet below the surface, its thickness determined by the annual rainfall, the island's size and shape, and the permeability of the underlying coral substrate. The boundary between fresh and salt water, known as the halocline, represents a delicate balance that can be easily disrupted by overpumping, droughts, or contamination from surface activities. The largest islands may maintain freshwater lenses thick enough to support coconut palms and other vegetation adapted to slightly brackish conditions, while smaller islands may have freshwater lenses too thin to support any terrestrial plant life. The natural vegetation of the Maldives consists primarily of salt-tolerant species adapted to the challenging conditions of small coral islands surrounded by salt water. Coconut palms dominate the vegetation on many islands, their deep root systems capable of accessing the freshwater lens, while their salt-tolerant nature allows them to survive occasional inundation by seawater during storms or extreme high tides. These palms serve multiple functions in the island ecosystem, providing shade that reduces evaporation from the soil surface, contributing organic matter through fallen fronds and coconuts, and creating microclimates that support other plant species. The understory vegetation typically includes hardy shrubs and herbs such as scaevola, which forms dense thickets near the shoreline, and various grasses and sedges adapted to sandy soils and salt spray. The boundaries between land and sea in the Maldives are fluid and dynamic, constantly changing in response to wave action, tidal movements, and seasonal weather patterns. Beach profiles shift continuously as sand is moved by longshore currents and wave refraction around the islands, creating areas of accretion where sand accumulates and areas of erosion where the coastline retreats. The process occurs gradually under normal conditions, with changes measured in centimeters per year rather than dramatic shifts. But storm events can rapidly reshape entire shorelines within hours or days. The coral reefs that surround each island provide natural protection against the most severe wave action, dissipating wave energy before it reaches the shoreline, and reducing the erosive forces that would otherwise quickly destroy these low-lying islands. Perhaps you have experienced peaceful moments near water, whether ocean shores, lakes, or rivers, that brought you similar feelings of tranquility to those we explore among these coral islands. If you feel inclined to share such experiences in the comments, others would find comfort in reading about the watery places that have provided you with peaceful reflection. The tidal patterns across the Maldives follow the typical twice-daily cycle of most tropical ocean regions, with tidal ranges varying from approximately 0.5 meters or 1.6 feet during neap tides to 1.5 meters or 4.9 feet during spring tides. These modest tidal variations are sufficient to dramatically alter the appearance and accessibility of many reef areas, exposing vast expanses of coral during low tide and covering them with several meters of water at high tide. The tidal currents that accompany these water level changes create complex flow patterns within and between the atolls, carrying nutrients, plankton, and larvae between different reef communities. The currents typically flow fastest through the channels between atolls and through the deeper passages that connect atoll lagoons with the open ocean, creating distinct marine environments characterized by different current speeds, depths, and nutrient availability. The temperature stability of Maldivian waters reflects the moderating influence of the vast Indian Ocean that surrounds these tiny islands. Surface water temperatures rarely vary by more than 3 degrees Celsius or 5.4 degrees Fahrenheit throughout the year, maintaining the consistent warmth necessary for coral growth and reproduction. The thermal stability extends downward through the water column, with temperatures decreasing gradually from the 28 degrees Celsius or 82 degree Fahrenheit surface waters to approximately 25 degrees Celsius or 77 degrees Fahrenheit at depths of 30 meters or 98 feet. This thermal consistency eliminates the seasonal diebacks and dormancy periods that affect marine communities in more temperate regions, allowing continuous biological activity throughout the year. The clarity of Maldivian waters contributes significantly to the productivity of the coral reef ecosystems by allowing sunlight to penetrate to considerable depths. Visibility often exceeds 30 meters or 98 feet in the clear ocean waters surrounding the atolls, enabling photosynthesis by coral symbionts and marine plants at depths that would be too dark in less transparent waters. The exceptional clarity results from the minimal terrestrial input of sediments and nutrients, as the small, low islands contribute virtually no runoff to the surrounding waters. The oligotrophic conditions that create this clarity also limit the overall productivity of the marine ecosystem, creating a beautiful but nutrient-poor environment where life must be highly efficient in capturing and recycling the limited available resources. Marine currents around the Maldives are influenced by both local tidal movements and larger-scale ocean circulation patterns driven by monsoon winds and the rotation of the Earth. The major surface currents generally flow from east to west during the southwest monsoon period and reverse direction during the northeast monsoon, creating seasonal variations in water exchange between different atolls and between the archipelago and the broader Indian Ocean. These current patterns affect the distribution of marine larvae, nutrients, and plankton throughout the region, creating connections between distant reef communities and influencing patterns of biodiversity and ecological succession across the archipelago. The deep ocean surrounding the Maldives drops rapidly from the shallow atoll platforms to depths exceeding 2,000 meters, or 6,560 feet, within a few kilometers or miles of the outer reef edges. These deep waters support different marine communities dominated by pelagic species adapted to life in the open ocean rather than on coral reefs. Whale sharks, manta rays, and various species of dolphins regularly visit the deeper waters around the atolls to feed on plankton concentrations that develop along current boundaries and upwelling zones. The interaction between shallow reef ecosystems and deep ocean environments creates one of the most diverse marine regions in the world, where species from very different habitats can be observed within short distances of each other. The human geography of the Maldives reflects the constraints and opportunities presented by life on small coral islands scattered across a vast ocean expanse. The total land area of all 1,192 islands equals only 298 square kilometers, or 115 square miles, an area smaller than many individual cities. Yet this tiny land mass supports a population of approximately 540,000 people distributed across 200 inhabited islands. The population distribution shows extreme variation, with the capital city of Malé housing more than 200,000 people on an island measuring only 5.8 square kilometers, or 2.2 square miles, creating one of the highest population densities in the world at approximately 35,000 people per square kilometer, or 90,000 people per square mile. In contrast, many of the outer atolls contain islands with populations numbering in the dozens or low hundreds, where traditional lifestyles based on fishing and coconut cultivation continue much as they have for centuries. The settlement patterns across the Maldives have been shaped by the availability of fresh water, protection from storms, and access to fishing grounds and transportation routes. Islands with the largest freshwater lenses and the most protected harbors became the natural centers for human settlement, while smaller or more exposed islands remained uninhabited or supported only temporary fishing camps. The traditional house construction utilized locally available materials, including coral stone, coconut timber, and palm thatch, creating structures adapted to the tropical climate, and the risk of storm surge from tropical cyclones. The typical island settlement concentrated houses near the center of the island, where elevation was highest and freshwater most reliable, with community areas such as mosques and schools occupying prominent positions within the village layout. Modern development patterns in the Maldives have been significantly influenced by the tourism industry, which has transformed many previously uninhabited islands into resort destinations, while concentrating the local population on fewer islands with enhanced infrastructure and services. The resort development model typically involves leasing entire small islands for exclusive tourism use, creating artificial environments designed to maximize visitor satisfaction while minimizing environmental impact. These resorts often feature imported sand, transplanted vegetation, and engineered coastal structures designed to maintain beach stability and protect against erosion, creating landscapes that appear natural but require constant management to maintain their appearance. The transportation networks that connect the scattered islands of the Maldives rely primarily on marine vessels ranging from traditional fishing boats called donas to modern speedboats and seaplanes. The dhonie design, with its characteristic curved stem and shallow draft, evolved specifically for the conditions found in Maldivian waters, allowing these boats to cross shallow reefs and navigate narrow lagoon channels that would be impassable to deeper draft vessels. The modern transportation system includes scheduled ferry services connecting major islands, speedboat transfers for resort guests, and seaplane operations that provide the only rapid transportation method capable of reaching the most remote atolls within reasonable time frames. As we near the deeper stages of our mental journey across these scattered islands, perhaps you might reflect on which elements of this coral island geography you find most conducive to peaceful relaxation. If you feel moved to share such observations in the comments below, many listeners find that reading about what brings others peaceful sleep helps enhance their own rest. The fishing industry that has sustained Maldivian communities for over 1,000 years continues to play a central role in both the economy and culture of the islands. Despite the growth of tourism and other modern economic activities, the traditional fishing methods developed in the Maldives demonstrate remarkable adaptation to the specific conditions of coral reef environments, utilizing techniques that maximize catch while minimizing damage to the reef ecosystems that support the fishery. Pole and line fishing for skipjack tuna remains the dominant method for the most important commercial species, with fishing boats using live bait to attract schools of tuna to within easy range of handheld fishing lines. This method allows selective harvesting of target species while avoiding the bycatch problems associated with net fishing methods. The tuna fishery centers on several species of skipjack and yellowfin tuna that migrate through Maldivian waters, following seasonal patterns linked to monsoon winds and ocean temperatures. The peak fishing seasons typically occur during the transitional periods between monsoons, when calmer weather conditions and favorable current patterns concentrate both fish and their prey in predictable locations around the atolls. The fishing boats venture out from island harbors before dawn, using traditional knowledge of current patterns, bird behavior, and watercolor to locate productive fishing areas. The day's fishing concludes with the return to harbor in late afternoon, when the catch is processed and prepared for local consumption or export to international markets. The reef fishery provides additional protein and income for island communities through the harvest of numerous smaller species that live permanently within the coral reef ecosystem. These species include various types of groupers, snappers, parrotfish, and surgeonfish that occupy different ecological niches within the reef environment. The traditional reef fishing methods include handlines, small nets, and fish traps designed to minimize impact on the coral structures, while allowing sustainable harvest of target species. The timing of reef fishing activities often corresponds with tidal patterns, as changing water levels expose different areas of the reef and create feeding opportunities for various fish species. The aquaculture potential of the Maldives remains largely undeveloped, despite the abundance of clean seawater and favorable temperatures that would support the cultivation of various marine species. Small-scale cultivation of seaweed provides supplemental income for some island communities, taking advantage of the clear, nutrient-poor waters that favor the growth of certain commercially valuable algae species. The seaweed cultivation requires minimal infrastructure and can be integrated with traditional fishing activities, allowing island communities to diversify their marine-based livelihoods without major capital investments or technological changes. The agricultural potential of the Maldives is severely limited by the small land area, poor soils, and salt spray that affects all terrestrial vegetation. Traditional agriculture focused on coconut cultivation, which provided food, construction materials, and export income while requiring minimal fresh water and tolerating the challenging conditions of small coral islands. Kitchen gardens utilizing imported soil and careful water management allow the cultivation of leafy vegetables and herbs for local consumption. Though the scale remains necessarily small, given the constraints of limited fresh water and land area, some islands have experimented with hydroponic cultivation systems that eliminate the soil requirements and allow precise control of water and nutrient applications. Though these systems require imported materials and technical expertise that may not be readily available in remote island communities, the waste management challenges facing the Maldives reflect the constraints of small island environments where land area for disposal sites is minimal and transportation costs for waste removal are high. Traditional waste management relied on the decomposition of organic materials, and the absorption of human waste by coral sand. Methods that worked adequately when population levels were low and consumption patterns involved primarily local materials. Modern consumption patterns that include plastics, metals, and other non-biodegradable materials have created waste streams that exceed the capacity of traditional disposal methods and threaten both terrestrial and marine environments. Several atolls have established centralized waste management facilities that serve multiple islands, utilizing improved transportation networks to collect waste from smaller islands for processing at larger facilities equipped with modern treatment technologies. Water resource management represents perhaps the greatest challenge for sustainable development in the Maldives, where natural freshwater supplies are limited and easily contaminated by human activities or saltwater intrusion. Traditional water management involved careful protection of the freshwater lens through restrictions on wells and conservation of rainwater during dry periods. Practices that required community cooperation and traditional ecological knowledge. Modern water supply systems increasingly rely on desalination technology to supplement natural freshwater supplies. Though the energy requirements and maintenance costs of desalination systems present ongoing challenges for smaller island communities. Rainwater harvesting systems provide an intermediate technology that can supplement other water sources while requiring lower energy inputs and maintenance requirements than desalination systems. The climate change implications for the Maldives include potential impacts from sea level rise, changes in precipitation patterns, and increasing ocean temperatures that could affect coral reef health. The low elevation of all Maldivian islands makes them particularly vulnerable to sea level rise, with even modest increases potentially affecting freshwater supplies and increasing the frequency of saltwater flooding during storm events. Changes in monsoon patterns could alter the seasonal distribution of rainfall, potentially affecting the recharge of freshwater lenses and the timing of agricultural activities. Ocean warming and acidification threaten the coral reef ecosystems that provide the foundation for both the islands themselves and the marine resources that support local communities. As our journey across these coral islands draws toward its close, we return to the endless rhythms of wind and wave that have shaped these atolls for millions of years and will continue to shape them for millions more. The tides rise and fall with mechanical precision. The corals grow their limestone skeletons grain by grain, and the islands persist in their delicate balance between sea and sky. The processes that created these scattered jewels of the Indian Ocean continue today with the same patient persistence that has characterized this archipelago since its formation. Indifferent to human concerns, yet providing the foundation for all life that these islands support. The trade winds that brought the first human settlers to these islands continue to blow across the coral platforms, carrying the seeds of plants, the larvae of marine animals, and the moisture that sustains life in this ocean desert. The currents that transport nutrients between atolls follow the same patterns established by the rotation of the Earth and the gravitational pull of the Moon, connecting these isolated islands to the broader cycles of the Indian Ocean and the global climate system. The seasonal rhythms of monsoon and trade wind, of calm seas and rough weather, repeat endlessly with variations so subtle that they can be detected only through careful observation across many years. In this realm, where the boundary between earth and water remains forever fluid, where islands appear and disappear with the tide, and where the horizon extends unbroken in all directions, we find a landscape that invites contemplation of vastness and permanence beyond human scale. The coral polyps that build these reefs work without consciousness or intention, yet their collective efforts create some of the most complex and beautiful structures on Earth. The fish that traverse these waters follow migration routes established over evolutionary time, responding to environmental cues that have remained constant for thousands of generations. The birds that nest on these islands participate in oceanic cycles that connect the Maldives to distant continents and remote archipelagos scattered across the vast Pacific and Indian Oceans. The gentle lapping of waves against coral sand continues through day and night, a rhythm as regular as breathing, as persistent as the heartbeat of the Earth itself. The water temperature remains constant within a few degrees throughout the year, creating conditions of stability that support the patient growth of coral and the slow cycling of nutrients through reef ecosystems. The clarity of the water allows sunlight to penetrate to the bottom of lagoons that may be 20 or 30 meters deep, illuminating sand patterns that shift and change with each tide, yet maintain their essential character across seasons and years. As consciousness fades into the peaceful realm of sleep, imagine yourself floating gently in the warm waters of a Maldivian lagoon, supported by the salt that makes these waters more buoyant than fresh water, surrounded by the soft sounds of wavelets against coral sand and the distant murmur of wind through coconut palms. The water holds your body weightless while your mind drifts across coral gardens where fish move in slow motion through a three-dimensional landscape of limestone arches and caves, following paths as ancient as the reefs themselves. And if this journey across coral islands and through tropical waters has brought you closer to the peaceful sleep you seek, remember to subscribe to join us on future explorations of our planet's most soothing landscapes, where the patient rhythms of geological time invite rest and renewal, far from the urgency of daily concerns.